Hi everybody, hi. Here we go again. Finally entered your grades from your old tests. Now I've got all the ones that people took pictures of. Oh, this is going to be a nightmare. Anyway, hope you guys are hanging in. Okay, so I'm going to go over the homework problems. It's all homework at this point, right? That we did with vertical motion. So, I don't really need to sketch this, right? It's going like that. Okay, ball's going up and it's coming back down. So in problem number 2, and this was the thing on CourseWeb, has an initial velocity of 90 feet per second, and then we have our gravity. So our velocity function, whoops, I'm going to use h for height. So h prime of t is going to be our 90 feet, our initial velocity, minus velocity of gravity. Easy enough. Position function, h of t is the integral of h prime of t dt. Remember? Okay, so h of t is going to be the integral of 90 minus 32t dt. So h of t is going to be 90t minus 32t squared over 2, and then plus c. This is going from the ground, so remember our c is just going to be 0, so we don't have to bother with that. And then this reduces to negative 16t squared. Okay, so that's easy enough, right? When will the ball hit the ground? Well, it starts on the ground and it ends on the ground. When it's on the ground, the height is 0. Oh man, this is a mess. Okay. Okay, so hits the ground when the position is equal to 0. So that 0 is equal to 90t minus 16t squared. It's a quadratic, so I'm going to factor out, you can factor out a t, you can factor out a 2t, it doesn't matter. It's not like it's going to be any harder. Whoops. Okay, so this guy times this guy equals 0. So if this guy equals 0, t is 0. Well, yeah, at times 0 we're on the ground. Or if this one equals 0. So if 45 minus 8t equals 0, that's negative 8t equals negative 45. And t is negative 45 over negative 8. That gives me 5.625 seconds. Okay, so that's how long it's going to take to go all the way up and back down again. Okay. Part E is when is it going to reach the maximum height. The maximum height is when the slope of the tangent line is equal to 0. The equation for the slope of the tangent line is the first derivative, which we did whenever we found our velocity function. So this is when h prime of t is equal to 0. Okay, so that's 0 is equal to 90 minus 32t. A linear function, all we're going to do is subtract 90 from both sides and divide both sides by negative 32. And that gives me 2.8125 seconds. Which, you know, if I'm starting on the ground and ending on the ground, I would just have to divide that by 2. It's going to take the same amount of time to go up as it is to go down. But, you know, why do that when you can do calculus? That's what I say. Okay, last part is to find the maximum height of the ball. So when I'm looking for height, I'm looking for position. So I know this is how long it takes to reach the maximum height. So I need to find h at 2.8125 seconds. And I get 208.1 feet. Okay. Don't worry about graphing it. That's just silly. It's just going to look like that. I can lick my hands because I never leave the house. So there we have that. Okay. So problem number 4. The only difference with this one, I mean, the initial velocity is different, but what else is different is that we're starting off from a height of 12 feet. So here, say you're, I don't know, on a porch roof or something that's 12 feet high, okay, and then you throw the ball up and it hits the ground. Okay, so our velocity function, oops. Try that again. Okay, I don't need to sketch what's happening. I did sketch what's happening, so there you go. Okay, so my velocity function is my initial velocity minus the velocity of gravity. My position function is the integral of this. So So I have 84t minus 32t squared over 2 plus c. In this case, my c is 12. And then that reduces, so I have 84t equals, 84t minus 16t squared plus 12. Okay, so part D. When's the ball going to hit the ground? It's going to hit the ground when the height is 0. So set this all equal to 0. And it's a quadratic. I can factor out a 4t. Right? So that's 21 minus 4t. Oops. That's, sorry, my bad. Can't factor that out though. Let's do this. I could divide everything by 4. I could use a quadratic formula. Maybe it's factorable, maybe not. I could use the vertex formula. Doesn't matter to me. Let's divide everything by 4. So that's 0 is equal to 21t minus 4 t squared plus 3. Yeah, that's not going to factor. Okay, so t is going to be plus or minus, I'm sorry, I'm screwing up all over the place. Okay, t is equal to b squared. Be careful. This is your b, is always going to be your coefficient of your variable to the first power. This is your a. It's going to be the coefficient of your squared variable. And then this is your c. Okay, so t is going to be equal to negative b, so negative 21, plus or minus the square root of b squared, 21 squared, minus 4 times a times c. Whole thing over 2 times a. 21 squared. And then negative times a negative is positive, times another positive is going to be positive. The 441 got 16 times 3 plus 1 squared. Okay, and square root. Okay, so t is going to be negative 21 plus or minus 22.1 over negative 8. Well, negative 21 plus 22 is going to be a positive number. Positive over a negative is going to be negative. Remember, you're going to have that because we're not starting on the ground. I don't want that one. I want negative 21 minus 22.1 over negative 8, because that'll be negative over a negative, and that'll give me a positive, which is what I want for time. So t is going to be negative 21 minus 22.1 over negative 8. Excuse me. Okay, so that's how long it's going to take until it hits the ground. Now, how long until it reaches its maximum height? It's going to reach its maximum height when the equation of the slope of the tangent line is 0. So that's when h prime is 0. So that's when 0 is equal to 84 minus 32t. So that's negative 84 divided by negative 32. Okay, now to get the maximum height, I'm going to put this value into my position function. So I'm going to find h of 2.625. Okay, and it makes sense. This is how long it's in the air before it starts coming back down again. And then you're starting from 12 feet above the ground, so you have that plus 12. So hopefully that makes some sense. 2.625 squared times negative 16 plus 84 times 2.625 equals plus 12. Ta-da! Okay, so hopefully you guys sort of understood this part. The next part, it's a little more algebra involved with it. So I know that makes everybody happy. This is really gross. Okay. Number 5. Okay, now we're looking for the initial velocity. Okay, if a ball is going vertically from the ground, if its maximum height is 550 feet, what does that velocity have to be based on gravity? Once in a while I'll have students say, well, what's the gravity for this problem? Well, we're all on planet Earth, so the gravity is going to be the same. It's going to be negative 32 feet per second per second. Okay, so anyway. Alright, so here's the deal. We have our velocity function, v sub naught minus 32t. V sub naught being your initial velocity. Okay, remember the sub naught stuff from pre-calc or from physics. Okay, so we know that much. And we know this. And we know max height is 550. That's all we know. We know what gravity is, right? So, okay. So let's get our position function. And we do that by integrating our velocity function. So it's v sub naught t minus 32t squared over 2. This is going from the ground, so my plus c is just 0. Okay? And again, we can reduce that. From this point on, when I integrate negative 32t, I'm just going to write minus 16t squared. Okay, because it's consistent since it's, gravity. Okay. All right, so I know that this equals that, and I know about this. That gives me two equations with two unknowns. I have to pare it down to one equation and one unknown. So if I use this, okay, what else I know, okay, let me do this. So my max height, okay, is going to be the t value, okay, when it reaches max height is based on position function. The max height I also know is when the slope of the tangent line is 0, when it's flatlined. So I have these two equations. I have v sub naught minus 32t equals 0. And I have v sub naught t minus 16t squared equals 550. Simple system of equations. Two equations, two unknowns. Pare it down to one. Well, since I'm going to be solving for v sub naught, I'm going to take this and solve for v sub naught in terms of t. I'm going to add 32t to both sides. So v sub naught is equal to 32t. Oh, sorry, yeah, that's right. Okay, so I take this value and put that definition in for this one. So you have 32t times t minus 16t squared equals 550. So this is 32t squared minus 16t squared equals 550. Well, this is 16t squared equals 550. Divide both sides by 16, and then take the square root. And we get, I think I already did this one. Yeah. We get 5.86 seconds for t. Then I take this value of t and I put it up here, and that'll give me my initial velocity. And velocity to me will be feet per second. Okay. If you want to hit pause now and try number 6, it's going to be just like this because it's from the ground, okay? It reaches a different maximum height of 485 feet, but everything else will be the same. So you're going to hit pause, do that, come back, and we'll go over that. Hopefully you actually did it and didn't just wait for me to do this. Okay, here's our velocity function, our initial velocity, our unknown, our gravity. Okay, take the integral of this to get our position function. It's going from the ground, so my c is 0. I have two equations with two unknowns, v sub naught and t. Okay, I know max height occurs whenever the slope of the tangent line is 0. And I know the max height is 485 because that's given in the problem. So there's actually my two equations and two unknowns. So I solve this one, v sub naught in terms of t. Take that definition of v sub naught and put it in here. Okay, so this gives me one equation with one variable. Easy enough. Combine your like terms. Divide both sides by 16 and take the square root to get t to the first. That gives me the number of seconds. Take this back up here and put it in here to solve for our initial velocity. And that's what we get, is 176.2 feet per second. Okay, so number 7, the difference here is we're starting from a height of 5 feet rather than on the ground. So by now, I guess you can figure out what we're going to do. That's just going to make that plus c isn't going to be just a 0, it'll be plus 5. Okay. So your h prime is still going to be v sub naught minus 32t. But when I integrate this, v sub naught t minus 16t squared, okay, because it'd be, remember 32t squared over 2, going to reduce it, plus 5. Right, where am I looking? Okay, so I know that when the slope of the tangent line is 0, that's my maximum height. I know because the problem tells me my maximum height is 730 feet. I have two equations for max height, two variables. We have to pare it down. Easiest thing to do is to solve for v sub naught in terms of t. Okay, add that to both sides. Take this definition of v sub naught and put it in here. So 32t times t is 32t squared minus 16t squared plus 5. I'm going to combine like terms here. And then I'm going to subtract 5 from both sides. Then divide both sides by 16. And take the square root. Okay, so I get the amount of time it takes to reach max height. Go up here and multiply it by 32, and I get my initial velocity is 215.4 feet per second. Okay, so number 8 is going to be just like this one. If you want to hit pause and try number 8, we're starting from a height of 10 feet above the ground, and the maximum height that the ball goes is 925. Okay, so 10 feet above, 925 feet is the maximum height. Okie dokie. Okay, here's our velocity function. Integrate it to get your position function. Here r plus c is 10, because we're starting from 10 feet above. Okay. I know that when the slope of the tangent line is 0, that's my max height. The problem tells me that maximum height is 925. So I have two equations, two unknowns. So just like before, I'll solve for v sub naught in terms of t. Then I'll replace the v sub naught in this equation with its definition. Combine like terms and subtract 10 from both sides. Divide by both sides by 16, and then I'll have t squared, so I need to take the square root of both sides. This gives me the time for max height, so I take that, put it in here, multiply by 32, and that gives me my velocity in feet per second, initial velocity. So those aren't too bad, hopefully. So I'm going to give you a couple of problems on vertical motion. And again, you know, you can scan it if you have a scanner and you want to email it, or use your phone and email it. This is the one instance where I prefer that you email rather than text me your answer, because it's kind of hard for me to look at it on the phone, especially if there's a lot of different parts, and we all do math kind of sloppy sometimes. Well, not all of us. I do. Anyway, okay, so it's BRU3. BRU 3 at pitt.edu. Okay, so next up, I put a link to Khan Academy to explain about definite integration. His intro lecture is identical to everybody else's, including my own. So why recreate that? Why reinvent the wheel? So I would like for you to take a look at that and keep your eyes peeled. I'll send out a couple of problems for you to do for a grade. And I miss you guys. Till next time. Bye-bye then. Bye-bye. Oops.